Today we're diving into a really fascinating new way to look at encrypted internet traffic. We're going to see what happens when you build a whole team of specialized AI agents to act like digital detectives, tasked with uncovering the hidden fingerprints of anonymity tools. So, let's jump right in.
So, right off the bat, here's the central problem. You're looking at traffic from 3 different anonymity networks: Tor, I2P, and John Donham. Now, by design, their encrypted data streams look almost identical from the outside. That's the whole point. So how could any system possibly learn to tell them apart without actually breaking the encryption? Well, that's the exact mystery we're going to solve today.
Here's how we'll break it down. First, we'll dig into the anonymity puzzle. Then we'll look at the AI agent pipeline that was built to solve it. We'll meet the specialist agents on the team, see how they turn raw data into actual insight, check out their final comparative report, and then talk about why this whole approach is such a big deal.
So let's start with the puzzle itself. Really effective encryption and anonymity tools are meant to be indistinguishable. It's like they're all wearing the same perfect disguise. They mask what you're doing by making all their data packets look as generic as possible. So the challenge isn't to look inside the packets. We can't. It's to find these tiny, subtle patterns in the behavior of the traffic itself.
And that brings us to the main objective. The goal here is absolutely not about breaking encryption. It's about building an intelligent system that can sift through raw network data, the kind of evidence you get from a capture file, and spot the unique telltale fingerprints that each of these services leaves behind, just based on how they operate.
So how on earth do you tackle a problem this complex? Well, you don't send in just one detective. You assemble a whole detective agency. And that's exactly the idea here. Think of this system as a high-tech investigative unit, where each AI agent is a specialist with a very specific expertise, and they all work together to crack the case.
And the workflow, the way the investigation happens, is pretty straightforward. A piece of evidence comes in, that's our network capture file, and it gets passed down the line. It starts with the flow capture agent, who gathers the initial clues. Then it moves to the temporal analysis agent, the size distribution agent, and the IP intel agent. Finally, after everyone has done their part, the report agent pulls all the findings together into one final, coherent report.
All right, so now let's actually meet these specialist agents, because understanding what each one does is really the key to seeing how this whole incredible system works.
First up is the flow capture agent. You can think of this agent as the first detective to arrive at the crime scene. Its job is to process the raw evidence and just get a basic lay of the land.
Okay, so what this agent does is take that raw network capture, a file called a .pcap, which is basically just a recording of all the internet chatter, and it brings order to the chaos. It groups all the data into logical conversations called flows. A flow is really just all the packets going back and forth between 2 computers. Then, using Google's Gemini AI, it writes up an initial summary and even suggests what the next agent should probably look into.
Next, the case file is handed over to the temporal analysis agent. Now, this specialist isn't interested in what's being said. It's interested in the rhythm of the conversation. For this agent, it is all about the timing.
So this agent starts asking some really critical questions. Is the data flowing in short, sharp bursts, like someone clicking around on websites? Or is it a long, steady, continuous stream, which might be a big clue that we're looking at a persistent VPN tunnel? These kinds of timing patterns are an absolutely crucial piece of the puzzle.
The third detective on the case is the size distribution agent. This one's like a forensic analyst, but instead of looking at footprints at a crime scene, it's meticulously analyzing the size of every single data packet.
And this can reveal a huge clue. See, normal internet traffic usually has packets of all different sizes, but a lot of VPNs will pad their data to make every single packet a uniform size, often the maximum size allowed, which is called the MTU. That uniformity is a massive red flag, and this agent is trained to spot those patterns of consistent sizing that scream encrypted tunnel.
Our final specialist is the IP intel agent. This is the intelligence analyst of the group, the background checker. It takes the IP addresses involved in all this communication and asks a very simple question: who are you, really?
And this is where raw data becomes actual intelligence. On the left, we've got a raw IP address, just a number. But this agent uses public APIs to enrich it, and suddenly, we know it's a public IP. It's in the US, it's run by Cloudflare, and hey, it's a known proxy. All of a sudden, a meaningless number tells a story. This is how the system can tell the difference between a regular home internet connection and a known data center used by a VPN service.
Okay, so at this point, our specialist agents have each filed their reports on a single piece of evidence. We've got pile of clues,
Now it's time to bring all those clues together and build a complete picture of what's going on.
This is where the traffic orchestrator comes in. You can think of it as the chief detective. Now, it doesn't do the analysis itself, but it manages the entire investigation for one capture file. It's the one that passes the evidence from one specialist to the next, in the right order, making sure the whole process runs like clockwork.
But here's the thing. Analyzing just one file isn't the real end goal. The true power of this system comes from solving the bigger mystery. What are the fundamental differences that separate Tor, I2P, and John Donovan?
And the final output is really where the magic happens. So here's a simulated quote from that final report agent. It's putting together clues from every specialist to draw a conclusion. When it says bursts of uniform MTU-sized packets, that's our packet size profiler's work. When it mentions known exit nodes, well, that's our IP Intel agent flagging addresses from Tor's public list. By combining these findings, the system can confidently tell the difference between Tor's structured traffic and John Denham's more random-looking footprint. It's not just connecting the dots, it's revealing the whole picture.
So this final report agent is basically the ultimate meta-analysis. It's not just looking at one case file anymore. It's taking the findings from dozens of captures, some of Tor, some of I2P, some of John Donovan, and it's telling a large language model like Gemini to find the deepest patterns that make each of these services unique. This is how it goes from analyzing single clues to generating a grand comparative theory of the case.
So, okay, this is obviously really cool for identifying VPN traffic, but what's the bigger picture here? Why does this approach matter for the future of AI and how we analyze complex data?
And here's the key takeaway. This whole system demonstrates a new and powerful way of thinking. Instead of building one giant monolithic AI that's supposed to solve a problem all by itself, you build a team of smaller, specialized AI agents. Each one is an expert in its little domain. This whole divide and conquer strategy makes the entire system more powerful, way more adaptable, and honestly, a lot easier to understand.
And that leaves us with a final, really interesting thought. This detective agency model worked brilliantly for network traffic, but what else could we use it for? Imagine a team of AI agents analyzing the chaos of financial markets, or looking for patterns in climate data, or even trying to understand complex biological systems. The possibilities are absolutely fascinating to think about.